that we can prove that it is possible to proceed with converting NFA to DFA and DFA to NFA. So in the last class, we have discussed how to proceed with converting this regular non-epsilon NFA to DFA, right? So here, let me give a brief overview and then we can proceed with. So this is the NFA. So for this NFA, we construct the transition table, right? So for from state to Q1, I'm having transition on input symbol A, I'm having a transition to Q1. For input symbol B, I'm having a transition to Q1 and Q2. So like that, we have consolidated, we have constructed this transition table. From this transition table, we are supposed to construct this DFA. How to proceed with constructing the DFA? So as you all aware, in the case of DFA, there will not be possibility for a particular input symbol from a particular state to have a transition to multiple states. So here you can see for input symbol Q1 from state Q1 for input symbol B, I'm having transition to Q1 and Q2, which is not possible with respect to the DFA. Okay, so here we can start with, so here you have to proceed from the start state, right? So we are going to construct the DFA from this NFA transition table. So from Q1, I'm having transition for input symbol A, I'm having transition to Q1. For input symbol B, I'm having transition to Q1 and Q2, right? So here I cannot go for transition for two different states. So I'm going to give a new name for that particular state, that is Q1 and Q2, right? So this is going to be a new state, okay? The next state is not going to be Q2. Instead, the states that are reachable from this state is going to be noted down first, right? Marked first, right? So here Q1 is already visited. So whereas Q1 and Q2, we are not marked it here, right? So we have to make the entry for Q1 and Q2. So how to make the entry? So here Q1 and Q2 for input symbol A, it will have the transition for union of Q1 and Q2. Okay, so here Q1, Q2 is a new state. The transition for input symbol A is going to be Q1 on input symbol A union Q2 on input symbol B, right? So what is Q1 on input symbol A? Q1. Q2 on input symbol A, NT, right? So Q1 union NT is equal to, is going to be Q1. And next is going to be, with regard to the input symbol B. So what is that? It is going to be Q1 on input symbol B, that's Q1, Q2, and Q2 on input symbol B, so that is Q3. So Q1, Q2, Q3. So yes, I cannot go for a multiple state. So let me name this as Q1, Q2, Q3. Right, so Q1 addressed, Q1, Q2 marked, and the next new state is Q1, Q2, Q3. So this is going to be the next state, Q1, Q2, Q3. How I can proceed with, so Q for Q1, Q2, Q3, for any symbol A, where will be the transition? It is going to be dependent on Q1 on A, Q2 on A, Q3 on A. Right, so it is going to be Q1 union NT. So it's going to be Q1. And with regard to B, it is going to be Q1, Q2 union, Q3 union NT. So it's going to be Q1, Q2, Q3. So yes. So here we have to mark the final state. So here in this case you can see Q3 is the final state. So which are the states that are having Q3 should be marked as final, right? So here you can see another example. Here Q2 is the final state. So here in this case there are 4 new states in DFA. We have constructed 4 states in DFA, right? Among these 4 states, which are the states that are companies with Q2? This and this. So this is going to be marked as the final state. Similarly, here Q3, here I'm having Q3, so this is going to be marked as the final state. Using this transition table, we can easily construct the transition diagram, that is the DFA. Okay, so now what we are going to do is proceeding with converting epsilon NFA to DFA. Okay, so here again it is going to be a very straightforward mechanism, no logic, nothing, right? Just a rule, set of rules to be followed. So please make a note. If you are knowing that rule, then you can very well solve this, right? So just a straightforward mechanism, no logic is required. Just following the rule will enable you to convert this epsilon NFA to a DFA. Hope you can identify this NFA, right? So what is this NFA? Already we have seen an example of converting a regular expression to NFA, isn't it? So that is going, this is the final NFA. So this is the final NFA for A R B star A B B. We have seen earlier, right? Using McNaughton-Emmett-Thompson algorithm. So using McNaughton-Emmett-Thompson algorithm, we will be constructing the epsilon NFA with epsilon transitions, right? So now what we are going to see is we are going to deal with an algorithm which enables us to convert this epsilon NFA to TFA. So this is called as the subset construction algorithm. Okay, subset construction algorithm. All right. Okay. So here we'll be dealing with the two functions. One is going to be epsilon closure. Another is going to be mu. Okay. So here we will see the meaning of each and every functionality when we proceed with. Okay. So here epsilon closure. So first what we are going to do. Okay. First, please make a note of it. Take it down. Take down. Epsilon closure of small s. So here please make a note, epsilon closure of small s. So make a note, set of NFA states. Please make a note of it, ma'am. Set of NFA states reachable from NFA state S on epsilon transitions alone. We will see the meaning of this function later. First note it down, right? So epsilon closure of small s is nothing but set of NFA states reachable from NFA state S on epsilon transitions alone. The next functionality what we will be dealing is epsilon closure of capital T, right? So epsilon closure of capital T. So here S is going to be a single state. Here T is a set of states, right? Okay. So epsilon closure of capital T. So please make a note of it. Set of NFA states reachable. So please make a note of it. Set of NFA states reachable from some NFA state S. Set of NFA, let me repeat, set of NFA states reachable from some NFA state S in set capital T, on epsilon transition alone, right? In epsilon transition alone. Let me repeat, set of NFA states reachable from NFA state S in T on epsilon transition alone, right? Next is going to be mu of T comma E, right? Mu of T comma E. So here please make a note of it. Set of NFA states on which, let me repeat, set of NFA states to which there is a transition, set of NFA states to which there is a transition on input symbol A, from some state S in T, from some state S in T. Okay, let me repeat. Set of NFA states to which there is a transition on input symbol A from some state S in T. Have you noted it? Yes or no, ma?
Yes, ma'am.
Yes.
Can you repeat?
Yes, which one I should repeat, ma?
Ma'am, the last one.
Yes, let me repeat, mu of T comma A. So set of NFA states to which there is a transition, right? To which there is a transition on input symbol A, from some state S in T. S is here it is small s. From some state small s in capital T. From some state S in T. Here S is small, T is capital. So here please make a note. Here we represent S in small because we are talking of a single state. Here T is represented as capital because in order to differentiate it as a set of states, right? Okay. Shall we proceed?
Yes.
Yes, good. Okay. So here in this case of subset construction algorithm, what we are going to do is first we are going to proceed with finding epsilon closure of start state. In this NFA, which is the start state? In this NFA, which is the start state and which is the final state?
0 and 10.
Yes. Do you all agree with this? Only one voice I could hear. What about others now? Yes, sir. Can you be able to? Yes, because so please make a note. This is the general convention. The start state will be designated by an incoming edge which comes from nowhere. Okay, it will be having an incoming edge which comes from nowhere, and it will be having a label as start. Okay, and then final state is designated by double circle. Okay, so here we can start with, so here first we have to proceed with the finding epsilon closure of start state. This is going to be the first step. So we have to proceed with finding epsilon closure of 0. Okay, so what is epsilon closure of? Yes, we have seen set of NFA state reachable from NFA state yes. Okay, yes, in the sense here 0. Set of NFA states reachable from 0 on epsilon transitions alone. Only on epsilon transitions, what are the states I am able to reach? That is going to be epsilon closure of 0, right? So here you can see, please make a note over here. Each and every state is reachable to itself on epsilon transition. Epsilon is nothing but empty, right? So each and every state will be reachable to itself on epsilon transition. So the first, if I want to find epsilon closure of 0, the first state that will be reachable is 0. Okay, 0 is reachable to itself on epsilon transition. That will not be explicitly represented. Okay, so each and every state is okay. If you are missing this one, then the entire resultant will be varied. Okay, so please make a note. Each and every state is reachable to itself on epsilon transition. So for epsilon closure of 0, 0 needs to be included. Okay, the next comes from 0 and reachable to 1. Okay, so here from 0, what are the states that are reachable by means of epsilon transitions? The entire path I'm going to traverse with the epsilon transition, right? So by epsilon transition, I am reachable to 1. From 1 by epsilon transition, I am reachable to 2 and 4, right? Okay, so here after this, I cannot proceed with it because I'm having the inputs in A and B. There is no epsilon transition. And similarly, here you can see from 1, I am having epsilon transition to 7. Okay, so 7, right? So epsilon closure of 0 is equal to 0, 1, 2, 4, 7. Right, so here I have found this set by starting with the start state, right? So we have started with the start state of NFA. 0 is the start state of NFA, right? So here I'm finding the set by means of finding epsilon closure of 0. Okay, so let me call this state as, so this is going to be the start state of my DFA. This is going to be the equivalent state. Okay, so this is going to act as the start state of my DFA. Let me call that state as, okay, let me call that state as A, right? So the next what we are going to do is we are going to deal with the function DFA transition. Okay, DFA transition of A comma A. So from state A, for input symbol A, where there will be transition. Similarly, for input symbol B, where I will be having the transition. That's what we are going to construct. So what is how to find the return of A comma A? Nothing but epsilon closure of A comma, right? Okay. So d tran of A comma A is equal to epsilon closure of mu of A comma A. So what is mu of A comma A? Already we have discussed. What is mu of T comma A? It is nothing but set of NFA states to which there is a transition on the symbol A from some state S in T. Here A, capital right? From some state is in capital A, right? So here we can start with, so what is A? 0, 1, 2, 4, 7. Okay, so first I have to proceed with finding mu of A, comma A. So what is mu of A, comma A? What is A here? 0, 1, 2, 4, 7. From this state, on input symbol A, where I am having transition, right? From this state, for input symbol A, where I am having transition. From 0, is there any transition on input symbol A? No. No. From 1, is there any transition? No. From 2?
Yes.
Yes, where I am reaching?
3.
3. 3. Right. So here again, next is 4. From 4, is there any transition on input symbol A? No. Right. From 7?
Yes.
Yes, I'm having transition to 8, right? So it's going to be 8. So mu of A, comma A is nothing but 3, comma 8. Now I have to find out epsilon closure of T, comma 8. So it is again going to be a simple thing. First I have to proceed with, that's what we have discussed, right? Epsilon closure of capital T. So it is nothing but set of NFI states reachable from some NFI state S in T on epsilon transitions alone. So here T is nothing but capital A, right? So here what I'm going to do is, T is nothing but this one, right? Capital T is what? 3, comma 8 here, right? So here what I have to do is, it is going to be epsilon closure. So it is going to be a simple one. It is going to be epsilon closure of 3 union epsilon closure of 8. Okay, first I have to proceed with finding epsilon closure of 3. So what is epsilon closure of 3? Epsilon closure of 3 is nothing but set of states reachable from 3 on epsilon transitions alone. As already discussed, each and every state is reachable to itself on epsilon transition, right? Okay. So what is epsilon closure of 3? So epsilon closure of 3 is nothing but from 3 I'm having transition to. So here each and every state is reachable to itself on epsilon transition. So 3 should be included. From 3 I'm having transition to 6. From 6 I'm having transition to 1 and 7, right? 1 and 7. From 1 I'm having transition to 2 and 4, and from 7 I'm not having any transitions, right? So this is with regard to epsilon closure of 3. And what about epsilon closure of 8? As usual, each and every state is reachable to itself on epsilon transition. So 8 needs to be included. So what about the rest? So is there any other epsilon transitions from 8?
No, ma'am.
We can stop at it. So here, please make a note. Just please make a note. Rearrange it, right? Because we'll be getting different states. So if it is in order only, then we can identify whether it is a new state or existing state. So for convenience, we are rearranging it, right? So because it doesn't matter, the meaning is going to be same, right? So here 1, 2, 3, 4, 7, 8. All right. So is this an existing state? I am having existing state A. So if these two states are new, if these two states are more same, no, right? This is a new state. So this is a new state. Let me call that as 1, right? Let me call that as 1. So what I'm going to do now is I'm going to proceed with, so for input symbol A, that is from start symbol VFX symbol A on input symbol one A, I'm having transition to B. Now similarly, I have to proceed with D tran A, comma B. So D tran of A, comma B. So what is D tran of A, comma B? Epsilon closure of A, comma B. So what is move of A comma B? So what is A? A is nothing but 0, 1, 2, 4, 7. Here let me note it down, right? 0, 1, 2, 4, 7. Okay. So from 0, is there any transition on B? No. From 1, no. From 2, no. From 4, from 4, I'm having transition on invisible B, right?
Yes.
Yes. So I'm having transition to 5. Next comes 7, there is no transition, right? So move of A comma B will have only 5. So the next I have to proceed with finding epsilon closure of 5. So what is epsilon closure of 5? As said earlier, each and every state will be reached between itself on epsilon position. So 5 should be included. Next comes from 5 I am having transition to 6. From 6 I am having transition to 1. And similarly I am having transition to 7. From 1 I am having transition to 2 and 4. Right? That's it. So it's equal to 1, 2, 4, 5, 6, 7. Already I'm having one state that is B. So what is that? 1, 2, 4, 5. Right? So here, is this a new state or existing state?
A new state.
So I'm going to give a new name. Let me call this as. Okay. So here, please make a note. With the epsilon closure of star state, we have found the star state of DFA. In order to proceed further, we constructed D-tran of start state on each and every invisible. We have proceeded with the D-tran of A comma A, for which we had the transition to state B, and D-tran of A comma B, for which we had the transition to state C. Now I have to again locate mark B and C. So what should I do? I have to proceed constructing D-tran of B comma A. And similarly, I have to construct D-tran of B comma B. Okay, so please do try constructing this. I will be randomly asking you for the answer. Okay. So what I should do? So what is D-tran of B comma A? It is nothing but epsilon closure of B comma B. I will give you a minute time. After that, I will be asking you for the answer. Okay. What is Adarsh?
Yes, ma'am.
Yes, what is D-tran of B comma M? Oh, okay, please make a note. I'm just randomly calling you. Please don't I hesitate to give you an answer. Okay, so if you are wrong, it is nothing. Just participation makes the main rule. Right? So what is B comma M?
An epsilon closure of move B comma B. You're asking about D trend of B,
This
comma
one,
B.
I'm asking
Okay,
about
okay, okay.
or of B, B
Okay,
comma A.
I was going about that one. Okay. Move B, comma B. So,
B comma A, I'm asking now.
ma'am, actually, I was doing that last one. Okay.
Yes, what happened now? Adarsh,
Yes, ma'am. Can you please show that screen?
yes. Okay. I think better we can work it out, right? So what is move of B comma A? So this is B, right? This is B. Now input symbol A, which are the states having transitions, right? So is there any transition on input from one? Is there any transitions on input symbol A? Adarsh, is there any transition on input symbol A from input state one?
No, ma'am.
Oh, so next is 2. From 2, is there any transition on input symbol A?
Yes, ma'am.
Yeah.
2 to 3.
2 to 3. So 3, right? From 2 on input symbol A, moving to 3, right? 3. Next is from 3, is there any transition?
No, ma'am.
Then 4, is there any transition?
No, ma'am.
Next is 6. 6, is there any transition?
No, ma'am.
7,
Yes, ma'am.
is there one transition to 8, right? And then from 8, I'm not having transition. So it's going to be epsilon closure of 3, 8. What is epsilon closure of 3, 8?
Epsilon transition of 3, comma 8, 3, 6.
Yes, 3,
6,
6,
1, 2, 4,
4.
and that's it, ma'am.
From
And
6, I'm
7.
having
7,
transition to
yes, ma'am.
7. And that is with regard to epsilon closure of 3. What about epsilon closure of 8?
Yes, ma'am.
What is epsilon closure of 8?
Ma'am, it will be 8 only.
Yes, good. So it is going to be, already we have written it, right? 3, 6, 1, 7, 2, 4, 8. Okay. So is this a new state? So if you are dealing with this one, you are getting a new state. What you will be getting is 1, 2, 3, 4, 6, 7, 8. So if I am proceeding with epsilon ratio 3, 8, I'll be getting this state, right? Is this a new one or existing one?
Existing one, B.
This is going to be. Similarly, I hope others would have tried with the trend of B comma B, right? Kutta, Bansari Kutta.
Yes, ma'am.
What about epsilon? What is so D trend of B comma B is nothing but epsilon portion of
Epsilon closure, move B, comma B.
what is mu? What is mu of B comma B? So what is B here? 1, 2, 3, 4, 6, 7, 8 is B, right? So B on input symbol B, right? So 1, from 1, is there any transition on input symbol B? What happened, ma? From 1, is there any transition on input symbol B? Vansudi,
And 4 and 2.
4 and 2. So from 1, I'm not having any transition on input symbol B, right? So please make a note. We are proceeding with move function, not epsilon function. So we are proceeding with the move function. So move for each and every state for that particular input symbol. I'll be checking whether there is any transition. So here, what is the input symbol checking? It is going to be input symbol B. From 1, is there any transition on input symbol B? Say yes or no.
No, ma'am.
From 2, is there any transition on input symbol B?
No, ma'am.
3,
No, ma'am.
4.
Yes, ma'am.
Where I am
To
transition
5.
5. I am having transition to 5. So 5 will be included, right? And next is yes. From 6, is there any transition on input symbol B?
No, ma'am.
7,
No, ma'am. From 8
8,
it is.
8. Where
Yes, ma'am.
having
8
transition
to 9
9.
and
Yes.
9 to 9
To 10 now. Please
and
wait.
9.
Please wait. Yes. Please wait.
Yes, ma'am. Yes.
Only in epsilon transition we'll be following that particular path, right? So as you say, from 0 and having transition to 1 on epsilon transition, and having epsilon transition to 1, from 1 and having epsilon transition to 2, 4. So the path will be following only in epsilon portion, where we'll be checking only for the transition. We'll be just moving to another, but based on that input symbol. Okay. So here, as you say, from 8, I'm having transition or input symbol B to state 9. That's it. So further, I should not proceed with the traversing. Right? Okay, is that clear? Are you clear with this?
Yes. Yes, ma'am.
Okay. So let me move on to next person. Right. Gautama.
Yes, ma'am.
Yes, ma'am. Can you please try? So what is epsilon closure of 5? So here epsilon closure of 5, 9 we have to proceed with. So what we have to do first, we have to proceed with epsilon closure of 5. Union epsilon closure of 9, right? So what is so okay? I should have the step. Okay. What is epsilon closure of 5? Gautama. Okay, what happened, Gautama? Please make a note. Please do try giving the answer. Please don't hesitate to give your answers. If it is not possible to give, please at least give the reason for not answering, right? Or else I'll be in a position to mark you absent. I should be aware whether you are present in the meet or not. Just joining the meet and leaving, it's not going to be a good one. Okay, Govind. Govind. Okay, please make a note. I'm going to mark absent for Gautama, Govind Agarwal. Harsh Parwal. Harsh, what happened, ma? Can you hear me or not?
Yes, ma'am.
Harsh,
I'm Govind
check.
texted in chat box.
What happened now? Okay, Mike. Okay, Govind, no issues, ma. Harsh again, Harsh. Yes, ma'am. Na? What, Harsh? You please give the answer, Harsh. What is the meaning for yes, ma'am? I don't know. Again, Mike not working. So I don't know what is the problem with you people. So if one is facing the issue, okay, fine. Govind, Harsh, I'm noting you down, right? So if today I'll be giving you attendance. So if the problem is persisting, please make a note. You okay, fine. Govind, can you please give the answer in the chat box for epsilon closure of 5? Laksha?
Yes, ma'am.
Yes, good. Okay, Laksha. Uh, what is epsilon closure of 5 now? Laksha, please make it fast, man. Time is running. Laksha? Are you there or not, huh? You're not audible. Okay, fine. Please make a note. This is going to be the first time. Except Gautama, for Gautama, I'm going to mark absent, right? So because he wasn't here, so he's not responding at all. Okay, so from next class onwards, I'll be randomly picking up. So for all the 63, I cannot ask the question. I'll be randomly picking up and I'll be asking questions. If not answering in the sense, I'm not talking of the correct answer. If you are not responding, then I'll be marking you absent. Because just joining the meet and then leaving, it is not going to be, giving attendance is not going to be the good thing. So you should be attentive in the class only then. So here, with regard to TOC, if you are attending, if you are listening to the class, then it is going to be an easy task for you. Okay, if not, then you will be feeling difficult. Okay, so okay, let me proceed now. So epsilon closure of 5. So please make a note. If it is not clear for you, let me give you the answer, right? So what is epsilon closure of 5? So it is nothing but, so each and every state is reachable to itself on epsilon transition, right? So 5 is reachable to itself on epsilon transition. So from 5, I am having a transition to 6 on epsilon. So 6. From 6, I'm having transition to 7 and I'm having transition to 1. So 1 and 7, right? From 1, I'm having transition to 2 and 4. So 2 and 4. From 7, I'm not having any epsilon transition, right? So are you clear with the epsilon closure of 5? Yes or no?
Yes, ma'am.
Can you repeat it once more?
Yes, of course. Good. Epsilon closure of 5. So it's nothing but, so each and every state is reachable to itself on epsilon transition. Okay. So 5 should be included in epsilon closure. This is not the case with move. Okay. So please make a note in epsilon closure. Epsilon is nothing but empty transition. Okay. Each and every state is reachable to itself on epsilon transition. So 5 should be included. So from 5, what are the states that are reachable on epsilon transitions alone? From 5, I am reachable to 6. So 6 is included. From 6, I am having transition to 7 and 1. So 7 and 1, that is 1 and 7 are included. From 1, I am having transition to 2 and 4. So 2 and 4 are included. Is that clear? From 7, I'm not having any epsilon transition, right? Is that clear for you all?
Yes, ma'am.
Oh,
Yes, ma'am.
then next is going to be epsilon closure of 9. So epsilon closure of 9 is each and every state is reachable to itself on epsilon transition. So 9 should be included. From 9, there is no epsilon transition, right? So that's it with this. So here we are having a state 1, 2, 4, 5, 6, 7, 9, right? Okay, so is this a new state or existing state? I'm having three states, right? I'm having A, I'm having B, and I'm having C. So what is C here? C is equal to 1, 2, 5, 7. Okay. Okay. Is this a new state or existing state? New. New. So let me name this as D. Okay, let me name it as D. So now I have completed D tran of I have marked A, I have marked B in it. Next, I have to proceed with marking C. I have to proceed with the sequence of process till I am not getting any new state. Okay, so please make a note. I have to proceed. So then I have to proceed with D tran of C comma A, D tran of C comma B. Then I have to proceed with the D tran of C, D comma A, D tran of D comma B. Right. So for that, I'll be having transitions, right? So if any new state comes, so for example, I am having E or F, so I have to proceed with finding out D tran of those states also. So I have to continue this process till I'm not getting any new state further. At one point of time, it will stop, right? Okay, so what I'm going to do now is try with proceeding. So till this point we have constructed, right? D tran of it's obviously 340. Okay, what you're going to do now is try constructing D tran of C comma A, D tran of C comma B. Try constructing D comma, that is, you have to complete the process. Okay, so you have to find out D tran of D comma A, and then you have to check what you are getting. If suppose you are getting a new state, okay, fine. If you are getting a new state, you have to give a new state name, and then you have to find D tran of what is that? C comma B. Then D tran of D comma A. D tran of D comma B. Okay, so you have to. So if suppose a new state E is coming, then you have to proceed with E comma A, E comma B. Like that, you have to continue and you have to stop the iteration when you are not getting a new state. Okay. So you have to, so we can continue this in the next class. So please make sure to complete this task. From the start of the class, I'll be randomly picking you and then I'll be asking questions. So please make a note. It is not good that is, if I'm asking question, please make sure to open up and give your answer. So please don't say yes. Reasons you are giving, I could. Okay, fine. Today I'm accepting your reason, but every day it is not possible because I don't know what quality of mics you use. Okay. Okay. So please don't say my mic is not working.